It's no secret that we're cramming crazy amounts of digital stuff into the next generation of cars. The trend that started with electric windows and door locks, yeah, that got me in trouble as a kid. Ouch. Gave rise to just about everything in cars being intelligent. From engines, brakes, and transmissions to driver assistance, comfort, and cabin entertainment. Now we're adding cameras, LiDAR, radar, and more, heading straight toward cars that can drive themselves. Now, if I can just get my car to go through the Starbucks drive-through for me. As we all know, those intelligent components and systems all need to talk to each other reliably over robust networks. And folks, that's exactly where this webcast comes in. Hi, I'm Amelia Dalton, host of Chalk Talk. My guest today is Vik Patel from Infinion Technologies, and we're going to be talking about transceivers for automotive design. We've got your CAN, we've got your LIN, we've got your, well, let's just dive in and find out, shall we? And before we get started, don't forget to click that link. There you can find out more information about transceivers for automotive design from Infinion Technologies. Hi, Vik. Thank you so much for joining me.
No problem. I appreciate it.
So, everybody is buzzing these days about self-driving cars, but before those autonomous vehicles can hit the road, we've got a major automotive overhaul coming in the form of vehicle networking, right? Let's talk about that.
Sure, yeah, I know the modern trend is everybody's excited about autonomous and self-driving cars coming on the road. And to enable that, one of the backbones really for self-driving cars is having a communication or network bus that really enables that. I think some of the features that we have today, we need to improve on and expand on to really enable self-driving features.
So, Infineon's been big in the automotive networking space for a while, right? Tell us a little bit about what Infinion does in this space.
Okay. In terms of Infinion, the first thing I'd like to stress is really we are committed, truly committed to automotive. We've been around in the automotive space for over 40 years. We have basically a system provider attitude in terms of we have a lot of products that can enable you to do a complete system. We obviously have a broad portfolio and we're improving that all the time. And you'll always hear the word chipset out of Infinion. This means that we're trying to provide the complete electronic chipset for one or particular applications in automotive. A current trend we're also adding to the portfolio of products is really functional safety concepts. I know, especially as we go down the road of having cars that drive themselves, you truly want to be safe. So we need to have a design that is verified and within the acceptable standards, the industry standards such as ISO 26262, and we're adding those features into our products. In terms of competitive benefits, we have leading-edge design expertise, especially in power and mixed signal circuits. We obviously have a strong system know-how, having been around for a long time in automotive and being close to our customers. And then a third point really is we see the transceiver market, and we know that really you need to have designs that are compatible maybe with somebody else's pinout. So in terms of the transceiver market, we do have common pinouts out there, enabling you to have a true safe and secure second source strategy, just in case something happens with the other guy. I mentioned partnerships and strong system know-how. This has come about over many years, and we have many partners in the automotive industry worldwide. We obviously have an excellent worldwide technical and sales support team in place in each of the major regions and automotive centers. And where we focus on in terms of designing, you'll hear the phrase a lot inside Infinion, is easy to use.
Okay, so let's dive into those transceivers a little bit. There's no one-size-fits-all in automotive transceiver land, right? Can you break down the various types?
Right, so I mentioned the word transceivers, and let me take a step back and just explain that really a simple definition of the transceiver is that it's a communication device that helps receive messages and obviously transmit messages on the vehicle network. So what do we have there? A simple picture here shows basically different types of automotive communication devices. Starting on the left there with the LIN transceivers. We also have CAN transceivers, or what we call now classical CAN transceivers. And now we have the new families, the CAN flexible data rate, or CAN FD families, and a CAN partial networking device. And on the far right there, we have something called FlexRay, which is a higher speed automotive transceiver. I will get into some of the details. I know that some of you probably are listening and thinking, well, there's other communication buses out there. I agree. Right now, we are looking into and investigating others, for example, Ethernet, which is coming into the car more and more, and then we'll look at some others down the road. But right now, what we're focusing on is what we have today.
And how does Infinion stack up in this space versus other competitors?
I think we have a very good market share. We're one of the leaders. I think there's probably two guys in the industry who dominate, and we're one of them. I think CAN is probably the major area of the business. We're refreshing the product line in terms of the new devices to meet CAN FD requirements, to meet these partial networking requirements. One of the key differentiators, I would say, versus the competition really is our quality. And not just the quality of our product, but really the quality of the design, the process, and the service. And I think this slide is a good example. It shows the Toyota Quality Award, the Honor Quality Award. We were the first supplier to win this Q award, and we've been excellent, actually, to such an extent that we've created a dedicated transceiver line just for Toyota vehicles.
All right, Vik, let's get into some specifics on various types of transceivers.
Okay, so starting off, LIN transceiver.
What is LIN and where should I use it?
LIN, or the acronym, what it stands for is Local Interconnect Network. It's one of the oldest buses and also one of the slowest buses in the vehicle right now. It's a serial network protocol, as you see written there, and it's basically used for communication between the various electronic control units in the vehicle. Where is it used? Typically today you see LIN used in areas like body control, so door and seat, HVAC applications, ambient lighting, which is a feature you see in modern cars, nice little different colored LED lights. These are controlled usually over LIN. And then one specific area, especially if you're using your rear camera and you put it into reverse, you see that camera coming up. They use a technology called ultrasonic parking, and that module usually communicates over LIN. In terms of what we offer, Infinion, we have 6 major device part numbers. And how do you even read those part numbers? This is the question. So TLE, as all Infinion products always used to start with, and 7 really indicates how the device powers up. 7, 8, or 9 is there. It powers up in a couple of different modes, whether it's sleep or standby, and a different variant of standby, 7, 8, or 9. And then -3, this is indicating a high-end device with additional features. And then if you see nothing, it's a basic version, or if you see the letter D, that means there is no transceiver timeout function available. The last 2 letters usually indicate what package it's in. So SJ is the classic leaded version, which is the PG-DSO8, which you see on the left there at the top row. And then LE would indicate these new, as they call them, leadless packages. So there are no traditional leads on these, and these are much smaller packages compared to the standard leaded versions. So these are defined by the phrase LE.
Okay, and if I'm using LIN transceivers, what options do you have for me?
So looking at the summary in terms of more details, we have basically 4 parts in the family. We have them in, obviously, the DSO8, as I described, or the leadless, what we call TSON-8 package. This is a 3x3 package, by the way. Starting on the left side of the slide there, we have the high-end LIN, as we call it, where basically you have additional features added in. The key feature that's really added in is this inhibit pin on the device, and this can actually control an external voltage regulator. So for when you need the transceiver to actually wake up a different device, you can use this function, the inhibit function, and this is where you would use a high-end device like the 7259-3GE. As you go down, you see more basic versions. So this is the 7257 and the 7258, which are 2 flavors of the basic LIN family. And what's the difference, you ask? The difference is really how it powers up. So the 57 wakes up into sleep mode, and the other wakes up for standby. And then we have an older device here, which basically works on K-line applications. We're seeing this less and less, but it is still available out there in the market.
Okay, there are transceivers, but another key trend for designers is making these modules smarter. So how does Infinion address that?
Right, good question. So here we have a product called the LIN LDO, which is essentially an integrated LIN transceiver plus the voltage regulator. So this is the part number TLE8457A and B. We have incorporated the linear voltage regulator, which is still compliant to the latest LIN spec, and then also a voltage regulator on board. It's a 70 milliamp voltage regulator, which can be stable with a 1 mic output capacitor. And obviously, you mentioned big trend is designers needing smaller and smaller modules, so smaller and smaller space is available. Now we've integrated two ICs into one. In terms of the benefits, obviously still AEC qualified, so automotive compliant. The integration saves on the IC count and the board space. Smaller external components, as I just mentioned on the voltage regulator. This lowers the BOM cost and the board space. And then with the voltage regulator, we have a lower system standby current. We had a previous generation of this where the system quiescent current was not so great. Let's say we're in the range of 20 microamps with this new family. We continue to have a very high robustness on ESD as we do with all our LIN family. And of course, in terms of board space, we even have it in the leadless package, so we really minimize the board space if you want to use the 8457 flavor.
So give me an overview on how these LIN transceivers compare and what's coming down the pipe.
So if we give a summary of what we have in terms of a LIN portfolio, we have obviously the single LIN. I start with the basic LIN, which is in production. These were the TLE 7257 and 58s. We have the high-end LIN now in production, which is the 7259 3GE. And as I just previously showed, the integrated LIN LDO. We have the first generation, and now we have in production the second generation with the improved quiescent current and the smaller output capacitors. In terms of integration, the theme continues. We now have twin LIN, as we call it, or some people call it dual LIN. We had a first generation device already in production, and we are now sampling the second generation dual LIN in also the leadless package now. And looking at the future, obviously the trend continues, and we're looking at a concept of a quad LIN, so 4 LIN channels in one package. It's yet to be determined which package we finally choose, but this is right now in concept. The message here is we are understanding the needs for integration, and we're trying to address that.
So what do I really gain designing Infinion LIN transceivers into my next automotive system?
Okay, so the two real USPs that I'd like people to remember. One on the left is what we've seen is a really, really good, in fact, top EMC performance, as the slide says. We fulfilled both the European and US car makers' EMC requirements with one device. I know a lot of the competition have multiple devices for different regions, so for different designs you'd have to have 2 different part numbers. We have one part number, and it meets the requirements both in Europe and America. And obviously on the right, the high robustness. In terms of the ESD robustness especially, we have been shown, especially in some testing in the US there, that we passed the plus or minus 85 volt slow transient, and in this specific case, the basic LIN device is passed without an external ESD protection diode. Now, we're not saying we guarantee you use it without the ESD diode, but this is up to the application use case. But we have been shown, in terms of the robustness, to be one of the most robust devices out there.
Okay, moving right along, what about CAN?
Sure. So, stepping it up. CAN's a controller area network for automotive systems. And we just spent time discussing LIN, and people say, well, you have LIN, why do you need CAN? Well, CAN, again, is a faster communication bus. And as I mentioned at the very beginning, where the automotive industry is going, we need a lot more data, and we need to move it along the bus in a quicker fashion. So this is what CAN was designed for many years ago. What we're realizing is that classical CAN in its current state needs to have a bigger bandwidth and needs to have a faster speed, an even faster speed. So this is where the evolution has gone now into, you see the symbol there, CAN-FD, which stands for CAN Flexible Data Rate.
So you said CAN is faster than LIN. Can you put some details behind that for me?
Sure. So in terms of being faster, so it's typical classical CAN. Here in terms of the data bandwidth and in terms of the speed, here we see that CAN, from classical CAN to flexible data rate, we are increasing basically the data content by a factor of 8. And then we're obviously increasing the data rate, i.e. the speed at which it's being sent down the pipe. So in terms of the different phases, so there's an arbitration phase and a data phase, we're increasing this by between a factor of 4 and a factor of 10 when we're talking about programming at the end of an assembly line. The message there is, and especially the requirement, if you want to go into these more complex systems in the future, is we need to send more data between the different electronic control units, and we need to send it quicker. So the answer really was CAN flexible data rate.
Okay, Vik, you've been throwing all these part numbers at me, and I have to admit it's a little confusing. Is there a decoder ring or something that would help me understand what I'm looking at?
Sure, just like in Lin, we have a decoder ring for CAN too. So again, the famous TLE at the front. And again, we have different numbers to represent different types of CAN FD. So 7 represents the 2 megabaud family. 8, as I mentioned in one particular slide, we have a dedicated family for Toyota. So anything TLE8 is just for Toyota. And then what's in development is the even faster CAN FD family, which is the 5 megabaud family, the TLE9. Then you get into, after a fixed value of 25, the different numbers. So 0, 1, 2, 3, or 5. What this indicates is whether the function has the bus wake or without bus wake. If it has a VIO or wake receiver embedded inside the device, it's a 1. Number 2 is a wake receiver on a different type of supply. And then 3 would represent a 2-channel version of the CAN. And then 5 finally represents the CAN partial networking device. There's additional, if you see the V, you understand you have the VIO function built in. If you see nothing, there's no VIO. And as usual, we finish with the package variants. So SJ again is SO8, LE is the leadless TSON8, and then in these families we also have SK and LC, which are the 14-pin packages.
All right, now just like we did with Lin, can you walk me through the CAN options?
Sure. Like I mentioned, there's 2 different distinct flavors. There's ones without the bus wake-up capability built in, and these usually end in a 0. You can see on the left of this slide here, this is the classical CAN family as we've been selling for many years in production, 7250G and the 7250G VIO, and these are already available. You can see the baud rate is at 1 megabit per second, considerably faster than Lin, but still not fast enough for modern application requirements. So here we move to CAN FD. And the good thing is, this is already in production. Anything TLE72 is already available, and it is backwards compatible to the classical CAN devices. As you can see, we've improved in certain areas in terms of speed and performance, but also kept up that ESD robustness and the compliance to certain vehicle OEM specifications. And in the not too distant future, we will have a faster CAN FD family, the 5 megabaud family, available in the standard package or the leadless package.
Nice, but what if I want my bus to wake up? Nobody likes a bus that just lies around asleep all day.
If you want the device to wake up on a bus message, 6251 has been around for quite a while. This is still the classical CAN family, still available and in production, and same step here. We've moved to a 2 megabaud version, which is the 7251 VSJ and VLE, and we've also got something in the works at the CAN FD 5 megabaud bitrate, which should be coming soon.
Okay, so what if I have an existing PCB, but I want to upgrade to the latest and greatest parts? What am I looking at here?
Pin compatibility. This is a common question out there in the design community, so this visual hopefully helps. So if, for example, if you have a 6251 in the classical CAN family or a 6250 or a 3.3 volt version, where can you go in CAN FD? As you can see here, you have a one-to-one direction in terms of drop-ins. So if you have a board already laid out, you already have an application where you're using classical CAN, we've made it simple.
Alrighty, and I assume that there are some new and improved CAN stuff headed my way as well?
Yes. Looking to the future, as I mentioned, we have the classical CAN and we have the CAN FD 2 megabaud, which is the 72 families available now. What is in development as a future path is the 92 family, which will be 5 megabaud. So basically, as the market is telling us, keep going. We need faster, we need better, we need smaller, we need tougher. So this is what we've developed. Hopefully we'll be rolling this out, let's say, starting in the summer and towards the second half of the year. And going into some of the details, what we're trying to do here is to have one CAN variant that's backwards compatible. So all the way from 5 to 2 to the classical CAN. We are compliant with the latest ISO 11896-2 spec, which is the standard, And then one key differentiator that we've learned recently is that we have a guaranteed wake-up behavior, maybe versus some of the competition who don't quite meet the latest specification there. And we do fulfill the worldwide filter time, and we have obviously one OEM variant, which is the Toyota variant. And then we have the typical performances in terms of symmetry, excellent EMC. We have some integration there, so we've removed resistors on our XD and TXD. When are these available? Obviously, we have samples available, but full production, as I mentioned, will be from the summer. We hope to complete the portfolio towards the end of the year for the new TLE 925X family.
You mentioned partial networking. What is that, and why would I want it? Don't people usually want complete networks?
Exactly. So let's go look at the CAN bus. Basically, today's automotive network with CAN works in this principle. One of the electronic control units sends out a message on the network, and every single electronic control unit in the car wakes up. Now, in some cars, that's up to 70 electronic control units. This means that the module is active, and if a module is active, it's basically drawing more power than if it was in a sleep state, and hence, it's burning more fuel. Now, vehicle makers really want to drive fuel economy, especially with some of the new legislation and standards coming in for higher fuel economy. What they're looking for basically is a way that the individual CAN message would only wake up the module that it was intended for, not every single module that's connected to that network. Then this would significantly cut down the power usage and improve fuel consumption. So the answer is, this is what partial networking brings. What it does is adds basically the capability to add a mailbox address to each of the modules in the car. So now you can send a specific message to a specific module, and only that module would wake up, whilst all the others would stay in a sleep state or low power mode.
I see, it's those sleeping networks again. So what devices have you got for my new and improved partial network?
Okay, so we define one specific device available in two flavors of packages, and this is called the TLE 9255, either the WSK or the WLC. So this is obviously compliant to the latest CAN specification and is also capable of CAN FD and CAN FD tolerance at the fastest speed of 5 megabaud. What's addition to it to enable the partial networking is basically, if you can see here, we've added the CAN controller into the device. Now, typical CAN FD transceivers don't have the CAN controller inside. This is typically inside the microcontroller. So in this range, you have a CAN controller and you have a SPI interface, an SPI interface. So you're able to communicate with different devices like micros at a faster rate and send these messages. So now you have a mailbox address system basically inside the transceiver. When it gets a message that is intended for its module, it says, yes, this is a valid message. I wake up the micro via the power supply. And of course, talking about low power modes, low power consumption is a key element there, and we have a very good number there, typically 16 microamps. And of course, we have, just like in the LIN, the ability to use the inhibit pin to wake up on whether it's a bus message on the network or even a local wake-up message. So we can control a separate power supply, voltage regulator inside the module and wake up the micro. In terms of availability, the standard package, so the PG-DSO14 with leads, is in production. The leadless package will be coming soon, July. So in this time frame of the summer, and again, second half of the year, we'll be ramping up availability of this device.
Okay, so let's back up to the 30,000 foot view. What's here today? What's coming soon? Why do I want to work with Infinion?
Yeah, so in terms of a summary, looking at transceivers and the key messages that start on the left. So for LIN, we basically have the entire family released, the basic LIN, the high-end LIN, and the new integrated LIN LDO. What's coming soon is the dual LIN in the new leadless package also. We have samples available. We should have the final product towards the second half of this year. And in terms of what we marketing guys like to call the USP, the unique selling point, it's really the ESD robustness is key in terms of our LIN products. Moving to the CAN FD devices. So we have released the CAN FD 2 megabaud devices, which are function and pin compatible to existing devices, so you don't need to tear up your board in your design there. And they're available in the standard leaded package, the DSO8, or the new leadless TSON 8 package. What's coming soon, as I mentioned, was the TLE 925X family, which gives you a CAN flexible data rate of 5 megabaud with the VIO pin, especially for 3.3 or 5 volt microcontrollers. And the same thing there in terms of packaging strategy. We have the leaded versions and the leadless version. Really, what is the USP in terms of CAN-FD? I think I'm going to focus in on the middle bullet there, which is we fulfill the filter time with one device. I know that our competition has multiple devices and multiple solutions out there. Really, we feel confident that the TLE925X can do that with one part number. And of course, we fulfill the latest wake pattern in the ISO spec. And moving to the partial networking, sadly, I can't say anything's released because, as I mentioned, the summer we will have the full release of the family. This is the 5 megabaud CAN-FD, but with the partial networking capability. The samples are available now, also with demo boards and some software support, and we're sampling in the standard leaded package and the leadless package. USP here versus other guys is really the current consumption in sleep mode. And then I'd like to highlight some of the things again here. So we mentioned the differentiator versus the competition in terms of our quality of not only the product but also the design and robustness, and also the service along with it. We get quality award from one of the major OEMs out there in Toyota. We have added the features of VIO supplied wake receivers in the new devices, and we have a flexible scheme whether you want to design with leaded packages or because of board space constraints you're going to leadless smaller packages. We offer the silicon in either one. And then the two final things in terms of the USP, excellent noise performance and excellent robustness, because the car network can be a noisy place. So you really want a robust communication device.
Okay, I think I'm ready to get started. Vik, where would I go for more information?
Very good point. So in terms of support material, so we obviously have a nice solution finder here. If you type in www.infineon.com/transceiver finder, you get this, which is now online, and you can select in terms of what type of transceiver you want, which type of microcontroller you have, and if you want certain features, and click on display results. It should come back with what's available and how you can order it and how to download the datasheet and any application notes that may be available.
Fantastic. Well, I think that's all I have time for today. Thank you so much for joining me, Vik. It was a pleasure speaking with you.
Thank you for your time.
And before we go, you didn't forget to click that link, did you? There you can find out more information about transceivers for automotive design from Infinion Technologies. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the on-demand section of eejournal.com or check out YouTube, keyword EE Journal.